Yeah. Someone can you guys anyone of review that? What did you learn last session? Yeah.
Yeah, we have created like we have done the deployment for the application. We have end to end. We have done like deployment and service of both the MLs we have deployed, and we have seen the end result, and we have learned about multiple commands, which includes like kubectl, apply, get nodes, get pods, describe nodes, describe service, get service. So all the commands and the usage of the commands we have seen,
Yeah. Yeah.
and even we have seen the response also, how it's going to be respond.
Okay. Mhm. So can you guys tell me like anyone how the request will go to the in Kubernetes induce a request flow?
Yeah, it will go to load balancer. Means that is pod load balancer. Uh, Load balancer to pod.
Mhm. Will it go directly to
Pod
the
to
pod?
uh,
This pod created because of whom?
worker
Deployment.
Deployment object.
deployment. Yeah,
Okay, deployment. Now this load balancer created because of
service.
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 So load balancer
Sorry.
service selected whom?
Deployment.
deployment.
Deployment. So load balancer request will go to the internal to the service. Under this service, all these pods IP will get registered, right? So
Right.
here, what is the keyword if you remember? If I describe the service,
Selector.
pod IPs, yes. Behind selector, yes. So this is the flow. So please, Kubernetes is purely virtual. It's not like the physically we go and then attach the load balancer. No, if we delete the pod, new pod will come. That new pod will automatically will register the service. How it will register? Because you have done a selector backend something under here. So we don't go to the GUI at all in the Kubernetes world majority times. No attachment of that. So all things are selecting that component, matching that name, matching the port number, all should goes well. Good. So now if you deploy 10 applications, uh, uh, like for example, 10 images, something, how many deployments will come?
10 deployments.
Deployment. Service objects,
Service also 10.
yeah. Load balancers.
10.
Same 10.
So some load balancers we will expose to outside world, right? Some we will not expose, right?
Yes.
What are those internal types?
Cluster IP, node
Yeah.
port,
Cluster
internal.
majority we will go with the cluster IP
Cluster.
within the node port, very specific use case up to that. Okay. So can you guys tell me here? I had given you this thing. I don't want to create, let's say I have 10 applications. I want to expose them all of them to. I have 10. All I wanted to expose to internet. 10 applications I have. All I wanted to expose them to outside. No internal, for example. In this case, you will get more load balancers count. So I wanted to avoid. How did you do in VMs? Same thing in the VM world, in the EC2.
We use Bastion.
Okay. End user point of view, I'm asking.
We use
We have
target-based host
target.
rules.
Target groups will create.
Currently, and then which load balancer type you have to go?
AL.
ALB.
That is what here, right? We will go with, no, if I get the same question, right? Like So it's all about the load balancer. If you go with the classic or NLB, they don't support the rule based. So we will end up with if more application count comes, we will have more load balancers. So because every load balancer registered with domain or something called path. So there is a one load balancer ALB will support rule based, path based and all. So that I'll create a one load balancer of ALB. There I will map multiple rules, paths and all. Behind it will have a target groups and all. 1 second. Yeah, that is what like you have to say that. So yes, target groups and all. So here what load balancer we will go in this VM's kind of concept.
ALB.
Application load balance.
Here you will have a simple listener. Here are the very important guys. What are those guys?
Rules.
Rules. And behind you will have a multiple. What are there behind rules?
Target.
Exactly, multiple target groups. Under those target groups, you will have a EC2 machines. Now, did anyone checked in the KTS how to avoid that?
I have checked. It's saying ingress is another Kubernetes resource that allows.
Yeah, ingress. That is a good keyword. Any others?
Nginx ingress controller.
Sorry.
Nginx ingress controller
Yeah,
is to
Nginx.
expose.
Nginx. Okay, Nginx. Ingress.
Automate load balancer progeny.
Yeah, right now also automated, right? If you deploy
Yeah.
this service, the load balancer, are you going to AWS console? Automatically, YAML is creating load balancer.
Right.
No, currently is
Yeah. Right. Got it.
automatically load balancer is creating, right? Currently also.
Yes.
We're not going to the console also. I'm giving YAML in the service. What is the one thing is specifying that load balancer? If you remember. In the service, what is the one type is creating load
Yeah.
balancer?
Load balance. Load balance.
Load type.
Type equal to load balance.
Load balance.
Yeah. Yeah. This is, can you guys tell me here?
Yeah, cluster IP is the one if you use that, it will be internal completely within the cluster.
Yeah, that is cluster IP. This is internal.
Internal
Now
cluster.
my objective was to outside only. I have like, for
Yeah.
example, 5 applications I'll deploy. So if you go with this model, right, the old model, how many load balancers will come? 5. I don't want to create.
If you have to expose the outside ingress controller.
Which load balancer we need to introduce here in this case also, in KTS also? Let's say
Application load balance.
whatever the
Application
load,
load balance.
Yeah, application load balancer.
you need to have application load balancer or application load balancer kind of one kind of guy who will have a rules, those things, right? So
Okay.
please, this is like majorly, if you understand this flow, remaining all are simple, like kind of layers only, just for application point of, you need to understand this. So what they did, they wanted to bring this kind of load balancer only, which will very important. These are what are the rules are currently we did experimented in VM. If you remember, we did, right? Cricket, football, something like that.
Path-based one was
Path-based host.
Path based and host based. Same way. Let me put it here in the image so that we'll have a clarity. I'm running some pods. Please bear with me with this thing, the image thing. One pod. I'll say the like these pods. On which nodes we don't care. Okay, some pods are running. Say that these are all one category pods. These are all some category pods. These are all same applications. Okay, all are running in the worker nodes. Okay, let me put it here. App 1. App 2. App 3. What is the one object is helping to create these pods?
Deployment object.
Deployment object. Now, these are all in the worker nodes, you think it. These are in the worker nodes. Okay. Now, service will not come to the worker nodes. Service is a altogether internal, it will be working with a queue proxy. We will not physically visualize the virtual. We cannot visualize that service object. Service is virtual. It is internally will be communicating with the queue proxy. Pods are physical, it is running on the worker node, you can think it. Okay. Now, for this also internally, you could have created one object, right? I want access from outside for this. What is the object?
Service object.
Service.
Service. You will say, for example, app 1. But what is the type you have to specify if I want access? Currently, what is the type you are specifying this currently?
Load
Load
balance.
balancer.
But what I'll say, I'll not specify it because what is the problem we are having with that?
Yeah, we can't create the multiple. Like we have to create multiple load balancers for
Yeah,
that if you want to create more.
that is
pods.
bit
Covered.
difficult, right? That is bit difficult to manage and all, right? Now I'm going to create, let's create a cluster equal to service type only. I'm sorry, service equal to cluster type only. Let's don't specify any type.
Edit.
Now I'm going to create one more object called ingress. Kind equal to ingress. You know already these concepts, okay? What are the topics, right? Already we explored it. Now we are bringing them to Kubernetes. You have to connect the dots. This ingress is nothing but same path-based, host-based kind of rules only. I'm going to create one more object like service ingress. Like you have selected, right? In the service, you have selected deployment, right? In this ingress, I will select service. This will forward to this will forward to this internally. This is kind of, you can think rules only. Rule. The path-based or host-based rule only. No. Host or path. Like this, it will have rules here. No. Now you will create it. But where is the load balancer? Still we don't have right here. All you are saying is the service type equal to only. For this, right, to support this, when you deploy this ingress, there is one YAML will be there, ingress YAML will be there. When you deploy this, these rules automatically will go one place. For this, right, in app 1, you are running application, app 2 also running application, app 3 also running application, right? I'll bring one more deployment that is nowhere related to application code and all. That is a helper pod which will reduce the load balancers count. That is called ingress controller. I'm going to deploy one deployment ingress controller. I'm going to deploy. You know already the story, okay? This is the deployment. 1 second. These are applications, okay? Whatever you are seeing above is applications. This I'm going to deploy one deployment name equal to ingress controller. There are different ingress controllers are there. Okay. For now, I'm giving ingress controller name. You remember last time, you guys saying some keyword, right? Istio, somewhere in the exam.
Yeah.
Yes.
I have mentioned. Yeah.
This is the guy.
Proxy.
This is the guy
Oh.
only, ingress controller. Okay. That is advanced one type.
Understand.
Like load balancer types are there, right? Classic, ALB,
Mhm.
NLB.
Mhm.
Like ingress controller, there are few types are there. One of the type you can say that is Istio. Now,
Got it.
now observe here, these are for applications you did deployed. I'm bringing one more helper pod, helper deployment, which will reduce the load balancers count. Now, what is the object here I'm going to deploy? Here you see it very clearly. What is that object?
Deployment.
Deployment. Because of the deployment, what pods will get created?
Ingress control.
Parts will be created.
Yeah, pods will get created, right? This is the deployment. Now, I wanted to expose this deployment to outside.
So yeah, we need to put type load balancer.
No, this is the deployment. What object I need to create? Extra one.
Service.
I'll create one object called service. This I will specify type equal to
Load balancer.
load balancer. Okay. Load balancer. Now, because of this ingress controller, right? Some more pods will come, right? Some pods.
Right.
Let's say that these are all what pods? These are all ingress controller.
Ingress.
Okay. Ingress. Say that ingress controller. Ingress is different. Ingress controller is different. You will get to know all those keywords. Okay, this is ingress controller. Here, some based upon the what is the type ingress controller you went. Now you got a load balancer. You got a, for example, you got a one load balancer. You think it. Oh, this load balancer has been created. This load balancer because of which object?
Service.
Deployment.
Which service object? You have here three service objects: app, service app 1, service app 2, service app 3, service ingress controller.
Service ingress controller.
About these service types, what are these service types?
Cluster.
Yes.
Cluster.
Yeah. Cluster.
This service type?
Load
Load
balancer.
balancer.
Load balancer. Now, what is the one extra object you are bringing here to define the rules here?
Ingress controller.
Ingress.
No, ingress controller is the deployment.
Ingress AAV.
In one object, you are specifying the rules here. In whole image. Somewhere you are
Ingress.
specifying the rule.
Ingress role.
Ingress, right? Here, ingress.
Yeah.
When you deploy, right? When you deploy this ingress object, automatically this rule will go inside this pod. They will take care. Automatically, these rules will go to these pods. The rules will go to these pods. Now, observe here. I'll take this load balancer endpoint. You know already the story, please bear. We have a load balancer. This load balancer got created from whom?
Service object.
Which service object? Application or ingress controller service object?
Ingress controller.
Ingress controller. I'll go to Route 53. I'll say www dot, for example, like app1 test, like app1 test.com, app2 test.com. Okay, for example, app3 test.com. For all, I will register same load balancer only. I will register here. Observe, please. This is very important. I'll register with the same load balancer only. In the cluster, how many load balancers are there now?
3.
No, one.
Sorry.
Load balancer. Load balancer is one.
One load balancer only, right? Now.
Yeah.
Yeah.
Now,
Right.
all this will go to the where now? Request will go to which one?
Ingress controller. Load type like ingress control service type load balancer.
Let's say as an end user, right? You are typing here, it will go to this load balancer right now.
Right.
Now, please connect the dots. You know already, okay? You know already. Just connect the dots. Let's go to the yesterday topic, okay? Let's go to the yesterday topic, okay? Keep this service ingress controller. I'll connect the dots again. You deployed deployment object. What got created?
Pods.
Pods.
Pods you cannot access outside because they are in the private network. They are in the worker also in the private network. You cannot access. You need one object to access them outside.
Service.
Service.
Service object.
When you specify service, what are you doing here?
Select
Select,
load
right?
balancer type.
Load balancer.
Select. What are you selecting here in the service?
Type.
Deployment. We are selecting.
Deployment.
Let me go here again back. I'll show you the YAML. This is my service. Okay. You forget this thing. Let's leave this guy. What are you selecting here right now?
Deployment
This is what?
Deployment.
object.
Deployment object.
Deployment object. Now, whenever you deploy service, right, automatically whatever the pods created because of this deployment, they will come, their IP address will get registered in the service in the endpoint section. Let me show you that. kubectl get svc. This is the service is there, right?
Yeah.
kubectl describe
Describe.
Test.
you see here somewhere.
Yeah.
This is your pod IP address only. This is pod IP. Whenever request comes to load balancer, this load balancer created because of which object here?
Service.
Service. Under service, who got registered here? Under load balancer previously.
Deployment.
Under target group previously, which components were there in the VM world? Under target group.
EC2.
EC2. Same way, under service, who got registered here? Pods.
Pod.
Exactly. Now write it here. Pods will get registered to service. Now let me ask you one question. Who is sending the request to pods here?
Service. Service.
Deployment. Service.
only.
IP.
Service only. Now pods. This service, because of this service, who got created here?
Load balancer.
Load balancer.
Load balance.
Now if you send a request to load balancer, internally you are sending to whom?
Service.
This
Service.
behind service, who is sending request? To pods.
Pods.
How? Because of this guy. Because of this guy, endpoints. So how many pods are running with this? You can come to know, right? How many pods are running here? Pods also will have private IP. How many pods are here?
One pod.
One.
Let's check it. kubectl get PO.
kubectl get.
How many pods are running? One. Let's
One.
increase one more pod. How can I do that?
Replica.
Which file?
ML file.
YAML file.
Yeah, which YAML file?
Deployment. Deployment.
Deployment.
Was
Static.
it, deploy 2.yaml. Here, right? ZT
Yeah.
2 kubectl
Apply alpha F. Deployed.
How many pods came now?
2.
2.
These 2 pods will register in where?
Worker node.
In service.
No, in this flow.
And service.
In
Service.
How can I check they registered or not?
Yeah. kubectl.
Describe.
Describe
SVC.
service.
Can you see
Yeah.
somewhere?
Yeah.
2 endpoints.
What is this guy? Endpoints only, right?
Yes.
Yeah.
Now request will go to the load balancer to service. Service does the load balancing. It will send here one. It will send another request one. It will send here another request two, another request three. Like this, who is do? You remember I was telling service is the virtual load balancer. Okay, in the Kubernetes. Now, cool. So load balancer to in the Kubernetes, if you want to access the pods, you need to go via
Service.
Service.
exactly. You need to go via always service object.
Service.
Now, you have the clarity. Service is the very important guy. Now let's come back to our image again. So here my pods are running. These are application pods, app 1, app 2, app 3. If I want to access this any one pod, I need to go via which guy?
Service.
Service.
Service object, right? If I create service equal to load balancer, what is the problem?
Multiple load balancer.
Manage multiple application with that load balancer.
Yeah, multiple load balancers will come, right?
Yeah.
Yes.
Yeah.
So it's a bit difficult. Now I want to avoid that. To avoid multiple load balancers, I'm bringing one concept called ingress controller. I'm bringing one deployment like app 1, app 2, app 3, right? Static website, something. There is a deployment called ingress controller. I will deploy this deployment. Thumb rule. Whatever the rule applied for your application also applies here also. Let me go here. Let me go back here. I'm going to bring one guy because of I don't want to go with multiple load balancers. I'm going to bring one deploy called deployment. This the ingress controller, you think it, okay? This is helpful object to reduce the load balancers. Now, apply the same rule, whatever for your application. Now, because of the deployment, who will get created?
Ingress controller.
Yeah, ingress controller only. But what will get created because of this deployment?
Load balancer.
Load balancer.
Pod.
Pods will create.
Always deployment is pod.
Deployment will
Yeah.
create what? What objects?
Pod.
Objects.
So who will
Ingress
get
pod.
here? Pods.
Pod.
In these pods, application will run or ingress controller will be running?
Ingress controller.
Ingress controller application. You think it ingress controller. This is end user application or our own, right?
Our own.
No Python, no Java language, something. This is our own. DevOps will own this thing. Okay. Now cool. Now pods are running. I want to access these pods outside. What object you need? Extra object.
Service.
Some rule. Whatever rule apply for your application also same applies here. Okay. Let's keep it. Now this service, I'm going to create one more guy. Service. This service I will expose as a what? Load balance.
Load balance.
The previous one, right? Let's say, let me put it here. The previous one, you will have a deployment app 1. Let me keep it here. Please bear with me. 3. And you will have one more object, right, to access these deployments to outside.
Service.
Service. This service I will not say load balancer. No, there is no load balancer.
Cluster.
I'll leave it to the default one, cluster IP. Okay. This service is equal to what it is? Cluster IP. Let's leave it. Default. I'll not specify any type. If I specify, again load balancer will come. Now, so cool. If you want access now in the cluster, all these are running in the K8s cluster. Okay, in the K8s cluster. If I wanted to enter into the K8s cluster, I have only one guy here from outside.
Load balance. Load balance.
Ingress control.
Service object.
These service objects you cannot access now outside.
Their internal access zone.
Yeah, in this one keyword is there if I wanted to enter from outside.
Ingress controllers.
We have to create ingress.
Okay. Okay, let's see. In this one guy is there from outside. I wanted to enter into the cluster.
Load balancer.
Load balancer, right?
Service.
Yeah.
This load balancer. This load balancer got created from whom?
Service.
This service is selecting which pods?
Deployment pod.
Deployment pods.
What is the deployment name?
Ingress control.
This is the guy. Sorry. This is the guy. Which is the guy?
Ingress.
Ingress controller. Now, request will go. Let's go here. End user. End user. End user will type like this. Okay. End user will type like this. End user will type like this. App one dot load balancer. This load balancer created because of which deployment among this? This is also one deployment. Let me keep it here.
Ingress controller.
Ingress controller deployment.
So this load balancer created because of which object among this?
Service.
This service is selecting which deployment?
Ingress controller.
Ingress controller.
Now request will go to the whom? Here, service, ingress
controller.
controller. Now this ingress controller is having, this service is selecting which pods?
Ingress control pods.
Yeah, these pods right here, these pods. Now, where is my application is running? App 1 is where it is running.
Deployment.
In this right here it is running, right?
Yeah.
Now,
Yeah.
there is a bridge, right? This is the one place. Let me keep it here. Let me keep it here. Let me keep it here. Because of this, who are running here, for example, pods. Let me keep it here before so that you will have a clarity. Always communication will go via service. This is the one deployment, this is another deployment. Both are in separate world. That's where I will create one object called ingress. One object type called ingress. In this ingress, this is the kind. Here I will say that, please observe here. If I want to send to this request to these pods, I need to go via. If I want to send a request to these pods, I need to go via
Service.
service. This is app1 service, let's say app1 service request. I'm going to create one object called ingress object. Here I will specify rule. What is the rule? If host name equal to
App1. App1.
something, forward to or whatever, like something, okay, forward to app1 service. Okay, else I'm going to bring one object called, what is that object? Ingress object.
Ingress.
Equal to ingress. In the ingress object thumb rule, what will be there? Rule will be there. That rule will forward to service. Same way in the service object, what information will be there? In the service object.
Service type.
In service.
Very good. Service type next. Service will
And select the deployment. Yeah.
deployment, right? Because of
Yeah.
the deployment, whatever comes, what will come because of deployment? I'm asking lot of times, you should get the keywords, okay? Because of deployment, who will get created?
Pods.
They
Pods.
will get registered here. This is the service object. They will register here. Same way, ingress will not select pods directly. Ingress will select service. In the ingress, what will be there?
Rules.
Rules.
When you specify like this, right, ingress, automatically that rule will go and then registered here. Here rule will be there. Here rule will be there. How the rule will come like this? If app1 is there, forward to this service internally. App1 service. It internally will pick. From here, the rule automatically will go here into ingress controller pod. That's how they designed it. The ingress controller will be scanning for keywords. Is there anything ingress came, kind equal to ingress came? The Kubernetes world, it will scan internally. If it is kind equal to ingress, automatically inside the rules, right, it will take. The rules will be here. Now, as an end user, you are coming, right, with these headers. We are coming outside. Now, this load balancer created because of ingress controller. Service type, request will go to service. Service will have a pods, right? These pods are not application pods. These are all ingress controller pod. Now, ingress controller pod automatically picked up those rules. This rule automatically. Now, request will go to ingress controller pod. Ingress controller pod has a rule saying that if this name comes, forward to whom?
Yeah. One.
Forward to service.
App.
App1 service. In the service, obviously, what will be registered in the service?
Type. Load balance.
Load balance type.
So pods will be just pods, I think.
Endpoints.
Endpoints, yeah.
What are these? What are these called? Endpoints are nothing but what are these?
Pods, I think.
Pods.
Pod IP addresses. They'll get registered. Now,
Yeah.
now this is not the load balancer type. This is purely this type equal to what type I told here. This is not the load balancer type. This is what type I was telling here.
Cluster IP.
Cluster.
Now from here to here, automatically request will come. Okay. Let me put it here all together. We are deploying some objects. One are application deployment objects. Application service objects. These service objects I will not expose as load balancer type. No, we will not expose them. If you expose individual each load balancer type, we will end up with multiple load balancers. I am bringing one helper deployment, which will reduce the load balancer. That is called ingress controller deployment. That will create what? pods.
Pods.
Thumb rule, if I want to access either application pods or any pod, what object you need to have? I'm going to create one extra guy called ingress controller. What object?
Service.
This service I will expose as a what?
Load
Load
balance.
balance.
Load balancer. Now in the Route 53, I will register this single load balancer only. This load balancer. Whatever request comes, this request will go to application objects or first it will go to this ingress controller pods.
Ingress control parts.
Here too, it will go to service. Under service, who will get there? Pods. Now from
Pods.
here to here, I need to send a request, right? From here to here. Here, I'll get one extra object called what is that?
Ingress.
Yes.
When you say
Rule.
ingress, automatically that rule will go to whom? Automatic. When you say ingress, right? You no need to please. These are all you cannot touch in the GUI. You should make a mind map that. When you specify that rule, you cannot see that GUI. You cannot see that GUI and all. Okay. These are all virtual. When you say ingress, automatically this will get picked here. It will go, that rule will go here. Now, request will go to load balancer to service. Now from here part 2, the request will go to your application service. Under this service, they will register with these pods. Any thoughts you want to ask on it? Now, how many load balancers are there with this?
One load balance.
One.
Whose load balancer it is? Application load balancer or ingress controller load balancer?
Ingress
Ingress
controller.
control.
So total into your any application, you have 100 applications also. How many load balancers will be there?
One.
How many ingress objects will be there?
Based on parts.
Based on the applications count and all those rules. Now, let me put it here. The end user flow now. Route 53. Load balancer. Whose load balancer endpoint it is? I'll put
Ingress
it.
control.
I'll say that ingress controller. Now request will go to the whom? Ingress controller. I'll say that service. Because of this load balancer created because of whom?
Ingress control service.
Service. It will go here. From here to, it will go to pods. Obviously,
Ingress control.
service will have a pods. Whose pods it is?
Ingress control.
Ingress controller pods. In these pods, who will be there?
Rules.
Rules.
Ingress rules.
Now, from this rule, we'll select your app1 service. This service will forward to whom? App1 deployment. Because of deployment, who got created here? Will be running.
Parts.
Pods.
Will be running. This is how. Now, what is this service type? This service type equal to load balancer or cluster IP?
Cluster IP.
Cluster IP. Now you go to the second application also same rule.
So in Route 53, how we can register this load balancer? Because same load balancer for the multiple applications, right? So I don't know, Mr. I'm just confusing. So how we can
Same, right?
connect?
How did you in the ALB also same thing, right? In the ALB case also, www dot, let's say for example, say app1 test.com, same load balancer endpoint only, no? You can register, right?
I understand. Register is fine, but see that application should come, right? While I registration, where we are mapping that. See here the same load balancer for app 1 and app 2, right? So
Yes.
rule, okay.
Yes.
Okay. Understand.
This
Understand.
this
Separate
rule-
agree.
Okay. Now let's go with that. Like we will compare with the VM. Okay. Let's go with the VM also. In VM, you will have a ALB, right? What are be there? What are the
Rules,
rules right here? In the
Yeah.
rules, you will have a like
target groups.
let's go like this. Okay. App1 test.com. In the VM world, okay.
Mhm.
For example, to make mind map is here. You will have how many targets group you will have like this?
3.
3, right? App1 TZ. Now you will have a app1 EC2. Here you will have a rule, right? Here you will have,
Right.
what is that? If rule is app1 test.com host to forward to this target group. Same. Let's go here as well. That you are doing physically. You go to the AWS console or with the Terraform also you can do physically. This thing, right? Apply the same rule here also. This is virtual. These rules are registered in the ALB, right? Now instead of ALB, right, these rules will register in the pods, in these pods. Here,
Ingress control.
all these rules will be there, all these rules. That these targets groups are, you can think this is, you can think this is a virtual. You can think this is the target group only. Into virtual world, you can think here. This is the one. This is equal to target group only. Service equal to target group only. No. Now this internally will forward to, here you are forwarding to EC2, here service will forward to whom?
Pods.
Pods. Exactly. How? This is the because of you selected that selector, right? Yeah. Yes.
Understood.
Obviously mind will not accept because we've been stick to for some days, right? This flow. Now this is the guy is the single load balancer. This is the guy total from here to here. This is the guy is the very important guy. Because of this guy, all the rules, everything, right? You think this the complete guy is equal to ALB. You think this is the ALB.
Okay.
This all together you think is all these guys are ALB. This you think as a target group in the virtual. This all you think as a EC2. If you want to compare old model to here. Now, where are the rules? Here. Where are the rules are getting registered? In the
Ingress
AWS
controller.
console, you will see in the GUI. Here you cannot see that. Automatically it will pick it up. The ingress object will pick it up. So extra guy you need to have here is the one guy. What is that guy?
Ingress.
Ingress object. Ingress controller is different. Ingress is different. Ingress is the
Rules for roles.
exactly that's it. Exactly rule. So you think this total concept equal to ALB. This is the target group. This is your EC2. That's it. This is ALB. You are bringing one ALB. Instead of ALB, right? In the Kubernetes world, ALB, if you want to create load ALB or load balancer, right? You need to have a service. We are not using application service. We are bringing one guy called ingress controller service. That service need a pods. We are bringing one ingress controller deployment. When you say ingress, that rule will go to pods. Now, which is the one critical pod shouldn't go down in this total. If that goes down,
Ingress controller.
Ingress controller pods.
very important. It shouldn't go down. If it goes down, all requests will fail, right? Very important. Ingress controller shouldn't go down. That is it. All your traffic will go via. Because why? All those rules are there in the ingress control pod only. Now it will go to here. Here it will check rules internally. It will check. That will forward to whom? To internally to service. Service it will go to pods. What is the one object is what is the one concept is reducing the load balancer?
Ingress controller.
Ingress controller. Exactly. Let me keep it here. Ingress. This is altogether one deployment, okay? Ingress control. What is ingress control? It is a separate deployment. It will have a own image. It will have its own service also.
Service.
It will have its. This service type equal to what?
Load
Load
balancer.
balancer.
Load balancer. No. How this works? When you deploy one object called ingress, if you deploy path based or host based, if you deploy ingress object, automatically ingress controller pods will pick these rules. They'll pick the rule. Now, Can anyone talk now just with the flow? Anyone? Whoever understood end user flow, please bear with me for some time.
Yeah. So it will go to first end user, from end user to
Route
route
50.
53, route 50 through load balancer, that is IC,
This load balancer created our application or ingress controller?
ingress control.
Yes,
That's what
Ingress
I-
control.
In the ingress controller, you have because of deployment or
Service.
subject.
Service.
So it will go to the
Service.
Ingress controller service, then ingress controller parts,
What's
then ingress,
yeah. Here who will come?
rules? Ingress.
These rules are what is that?
Ingress.
ingress,
Here our application will come now. Next,
Visit
your application
service.
service,
service. Here we have it.
Two pods.
These parts are created because of
deployment.
this is the no. This service I will not expose as a type what now? No one words. I will not
This
expose
is now
Load balancer.
no load balancer. This is internally
Yes.
what type now?
Cluster.
cluster.
Cluster
Cluster.
IP.
We should be very careful on this guy. It shouldn't go down. That's all. Good. So this is the flow. Now onwards, the load balancer count got decreased, right? So there are the ingress controller types are there. First one, right? These guys were there. This is the people who invented this ingress controller. People called Nginx ingress controller. Okay. This is the guy. These people, Nginx people. They brought this ingress controller deployment. Next, what AWS people and all, right? Like Kubernetes invented by whom first? Google, right? Then AWS took that Kubernetes code. They are selling as a right now what market in the AWS?
EKS.
EKS.
Same way, this Nginx ingress controller, AWS people took now, they're selling outside as a like this. AWS ingress controller. Now everyone like Azure ingress control, like everyone have their own ingress controller. Like one more, Istio, Istio controller. We say Istio controller something. So everyone is selling, but for all of why everyone is going with this concept is this is the objective. They wanted to go with the reducing the load balancers. They want to play with the rules, path based or host based kind of rules and all. These are all. So there are many are there right now in the market. You will be listening these keywords. Many are there. One more something Kong also. Kong ingress control. All their objective was reduce the load balancers count, have a rules. They will internally will forward all their objective. This is their objective. Now let me show you one image so that you will have very clear. Previous class to this class is ingress controller. Earlier we were having service type equal to no. Now only the one guy ingress controller will face all end users. Let's go to AWS ingress. You no need to touch anything. Already they had given it. We need to follow their standard for ingress controllers. You see here something? Internally, you see, right? This is where the rules will come. Internal. You no need to touch anything. This we don't touch in the GUI anything. Okay, let me go for previously. Some samples are there. Some samples. This is the one more ingress controller. AWS NLB. You will have a very clearer example. Okay. There are the G. This is 2019. This is 2018. That's okay. Now, yeah. Service is getting registered by whom here?
Parts.
Parts. Who is sending a request to service here? Which object?
Ingress.
Ingress. Now let's go here. Now you see it with the this is with ingress, the load balancer. Now, same flow. Request will go to the load balancer. This is the load balancer image that internally will send to the ingress. Advantages. There is one more was there. 1 second. What this document is saying, right? Let me show you what it means. In the AWS Ingress controller, they have two types again. What is that? ALB and one more is called NLB. That's what I'm saying. We will see that. There is one image, very clearer image. Yeah. Put in Windows. You see here, all these domains are going to whom?
Ingress control.
No. This guy.
Ingress
Network
control.
load
No.
NLB.
Load balancer.
Exactly. Let me go with this. All your requests will go to load balancer, right?
Load balancer.
This load balancer created because of
Service.
Ingress controller service.
Control.
Same. All together, this is the guy. This is the ingress controller. From here, it will internally forward. That's what they're saying it. Simple. So let's go now. We'll take something. I'll follow this document. Let's see. I'll go with NLB. Let's see. I have discussed these points. I'll reveal back again. Okay. Now let's go. I put this document. You have to follow these steps as is. They are given these instructions. We don't follow in companies also. We follow copy paste saying code only. Their structure. Let's go here. They had given some. You know already this understanding basics. How to use NLB ingress resources in Kubernetes. Observe this YAML, please. Bring this. Please observe some keywords. These labels can be any name. Don't care on those labels, okay? Observe this. You know some YAML specific, right?
Yeah.
API version. Kind.
Needs a namespace.
Data.
Metadata, right? This you can give anything. Now observe what is this kind type.
Namespace.
Get these keywords, okay? Next one more.
Service.
I'll tell you easy way, okay? I'll tell you easy way. Service account to user. I am user in AWS. In Kubernetes, right? User is called service account. Thumb rule. That is the keyword. I'll come. One more. What is the keyword here?
Config map.
Config map.
I'm observing the kind only, okay? One more.
Cluster role. Cluster role binding.
Cluster role binding.
Yeah, role. Role binding.
Yeah. Here you know one guy.
Service.
I'll pick this guy, okay? I'll pick this guy. Take this guy. I'll take these sections, okay? They had given one YAML only. Let me take this one. Let's take this. Don't care on the labels, okay? Labels will be more. Don't think on it. Let me bring it up. New folder. This is Ingress. In this service.yaml. Please don't get confused. These are all like, you can give as many as labels. Don't think cut up. Just I'll keep one name only. Let's remove namespace also. Okay. Now, here. What is this service type? By default, this service type. What is this service type?
Ingress controller.
Type.
Cluster IP.
Cluster IP.
Cluster IP.
Cluster IP.
To whom it is sending the request here?
Ingress control.
Ingress service. Ingress controller pod.
Okay, where it is sending? Where it is sending to pods and all? Where are you telling which pods the service should send request?
Type. Selector.
Are you getting my question?
Yeah.
Ingress.
Where do we say in
Ingress.
service? where do we say let me go. Okay.
Tech.
Okay. Let me go. Where are you saying to which ports we are sending request here?
Spec selector.
Elect.
Okay, right?
Yeah.
Selector also, right? Here also, where is that?
Below last. No. Type.
You can
Yeah,
give
below.
more than, you can give many also, not a problem. Let's say
Yeah.
this is they went with their label, okay? This is they went with the
Mhm.
label. No. Now let me go back again. Now is load balancer will get created because of this? Because
No.
of this?
Cluster IP, it is no.
No, right? No.
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 Now go back. Go back to same ML. One more, what
Yeah.
is
Service.
now copy this layer. Copy this guy. Copy from here to here. This is the selector. This is the section. Now one service is there. Now one more copy here. Don't care. No, this is important. When you say, right, I wanted to specific load balancer, you remember I was telling right last time, you need to have a specific annotation. You are saying here NLP. Now
NL.
let's go here. You have to follow this standard mandatory. That is the one. Namespace. Let's remove here. Yeah. Let's remove this also. Yeah. No. Where are you saying here to which part the request has to go? Same question.
Ingress controller. There is a label.
Ingress control.
No, you are listening my question?
Ingress rules.
Here, no. I'm talking only on the service.
Okay.
In this, where do we specify to which pods request should go? Who will send the request to pods?
Service.
Obviously, service only. True. In the service, where do we specify that to which pods request should go?
Selector. Deployment. Which deployment?
Where are they specifying here? Selector
Selector.
only, but you don't specify directly. I cannot bring every time. You cannot say that deployment and all. I'm asking A to B, B to C, A to C exactly. What is my question is? Where do we specify service will send a request to pods?
Selector.
In selector.
This is the guy. Okay. Selector. What is the subject?
Service.
Service subject.
Because of service, who will get created here?
Load balancer.
Load balancer.
Load balance.
NLB. This service will send a request to whom? This load balancer will send a request to whom internally?
Ingress controller. Pod.
Service to these pods, right? These pods.
Yeah.
What is this? What is this section? You can say what is this is called?
Ingress controller deployment.
Deployment. Deployment, right? You can specify this as a deployment. Okay. Now let me put it here. I'll go to this note only again. I'll go to here. You have this is the one you are watching right now. This is the one you are watching. This service equal to what? Load balancer. This load balancer is selecting to whom? Pods. That's it. So if you deploy this YAML, right, automatically will get one load balancer. Which load balancer we are getting? NLB. Why NLB is preferred? Why not ALB? We will see that. No. Now you see, right, which load balancer you are going, right? You know now which load balancer you are going.
NLB.
NLB doesn't support, right? What it won't support?
It won't support HTTP requests, HTTPS and all.
No, it doesn't support rules at all, right?
Yeah.
Right.
Yes.
Now you need a one guy, right, to support rules. Who will
Ingress.
support that guy?
Ingress.
These pods.
ALB.
These pods. No. We don't go with the ALB. These pods. Instead of
Yes.
ALB, right, we are going with these pods. These pods have intelligence of the, like, they will behave as a like kind of ALB. In these pods, rules are there. Now go back to this YAML again. What is this guy?
Deployment object.
Deployment. This name somewhere, right? Where is this guy? No, labels. Yeah, this labels. It will match with these labels. This name, you see here, these names are matching or not? You see here. Service will select whom? You know already.
Deployment.
Deployment. This name it matching. And because of the deployment, who will get created?
Pods.
In the deployment, you should give what?
Service.
In the deployment,
Image.
Images.
you will give an image, right? This image.
Yes.
This
Yeah.
image is this people image. We are going with this image and all. Please, we will not touch this YAML at all. We will take this YAML, we will deploy. You should know the theoretical concepts. We don't touch in the real time also, we don't modify it. We will take their YAML as it is, we will deploy. But please, I'm telling again, Kubernetes is the altogether mind mapping. If you did in the VM level, same concepts. Here all are virtual. Okay. Now deployment, you are deploying it. Don't care about these guys. These are all one more object, one job will come. I'm just seeing the kind type. Okay, one more kind, role, one more service account. In Kubernetes, service account equal to user. Okay, take. Cool. Take this YAML as it is. Earlier we used to download, right? You can deploy like this also. In the internet, if you have a YAML in any website, you can apply directly that YAML also. You no need to have local also, no need to have it. You can apply like this also directly. Copy this. Apply like this. kubectl apply. You can give internet YAML directly. You no need to download that. You no need to keep in the laptop also. No need to do that. Just give that internet URL. Let's see what will happen. One guy failed. Observe here. Observe the keywords for created. You know some keywords.
Oh.
Service.
Deployment.
One more, what got created here? Deployment. So deployment got created right here. What is the deployment name?
Ingress control.
Okay. Now let's see. Previously we also deployed our application, right? One guy.
Load balancer.
No. Previously we deployed our application, right? What is
Yeah.
the application name?
Static website.
Static. Our application name. Static website, right?
Website.
What is, we deployed one more now? One more. What is this application name?
Ingress controller. Nginx.
So how many pods, how many deployments should be there now? 2 deployments, right? For example, one is the static, one more is the Ingress Nginx.
Yes.
Let's see. kubectl get
Deployment. Yeah.
what is about deployment name?
Nginx
controller.
Ingress Nginx controller.
Do we have that here?
No.
No.
Simple, okay. Please observe here. This is the, in Kubernetes, you should know this topic also. One of the remaining all are the ingress controller is the one, I would say, my point of view, right? Ingress controller is the one very important. Remaining all are like isolated. Just you should know that ingress controller is the very critical mapping component. That's my I feel always. Next, why I have deployed which object, if you remember?
Ingress controller.
But it is not showing in here, right? What is that command? kubectl get deployment. It is not showing there. Why? I'll tell you. Here, right, in your you created EC2. Okay. One guy created EC2. One guy came to my project newly. He created EC2. He went into the AWS console. Off topic, okay? Just you have to tell me. He created it somewhere in EC2. Next day, he went into the AWS console. EC2 is running still, but he was not able to see the EC2 mission. What could be the problem? Just tell me. EC2 is running. He's telling that what you can check back, what you can think. He's
First
saying
thing, he is in the same region or not.
exactly. He may be checking in another region, right?
Right.
Region is the one is separating, right, your resources in AWS. Let's say if I say regional, if I say region, EC2, load balancer, EBS, like the resources, whatever you created, security group, VPC, all are under one region, right? This and all. If you switch to another region, you cannot see, right? Region
Right.
is the one grouping your all resources under one component, right? Same way in Kubernetes, when you deploying a service, pods or some Kubernetes objects, you have to deploy like a region, right? There is a concept called namespace. Namespace, what it does? Groups the objects
Object.
like deployment, service, something. If you don't have this namespace, right, it's very difficult to find where and all resources. Reason is the one very clearly specifies, right? Like something, this is the specific region, neatly well organized, right? Region is. If you keep all of them in one place, very difficult to find, right? Same way, namespace is the one groups objects and isolates also. Individual objects. Very neatly. With that, right, if you see here, go for top. What got created here?
Namespace.
How do you get it? This is the component. kubectl get ns. You see matching with one name. What are the namespaces are there here?
Ingress engines.
No, what are the namespaces are there here? Default.
Default, demo, Ingress Nginx.
What is the time of the Nginx ingress created?
4 minutes back.
1 minute back.
4 minutes back, right? Now, if you say kubectl get kubo, by default, it will search in this namespace by default.
Yes.
Now, what is my objective? I want to see Ingress Nginx pods, Nginx Ingress deployments. I want to see. If I want to space other namespace, right? Other than, if you don't pass namespace name, by default it will search in where? Default.
Default.
Now I wanted to know in this one. Then you need to explicitly you have to specify like this -n
Namespace name.
ingress name. That is what it specify here. Observe here. We deployed our application also, right? We deployed one more, na? What is our application name?
Static website.
Where is that? In which namespace that is there?
That is default one. We did not.
In which namespace that is there?
That is in
Default.
default.
How can I check my application pod is running or not?
kubectl get PO.
Kubectl
Get
PO.
PO.
You can specify like this also. But is it mandatory to specify?
No, it
No.
is not mandatory.
Just remove it. No. Now, what is your thought? Why do we need a namespace?
To group all the objects.
What is the benefit with that?
It will be there as a default. It will come under
We
an
can
umbrella.
It will divide like suppose production UAT.
Exactly right. You are not keeping all by if you don't
Yeah,
specify namespace, all will go to each namespace.
Yeah, default.
When you want to search and all, right, it is very difficult, right, to search to check something and all. If you have like this very neat, right, now which are all getting listed here? Which namespace one it is getting listed here? Here. Which namespace one getting
Ingress
listed?
Ingress.
Nginx.
Here.
Default.
Static
Default.
website.
Now let's see what are in this kube system. Let's see. Tell me the command. What are the pods are I want to check in this namespace?
kubectl
kubectl
get PO
get PO.
-n
Kube system.
right kube system.
There are some are running. AWS node, one is code DNS. This and all don't touch. Please don't delete also this error. Kube system is like if you touch it, it will break the total cluster. Don't touch this. these things. Okay, cube system, leave it. Now, so every time, right? This is the thumb rule. In original our projects, right? We never deploy anything in the default. Never ever deploy. Default namespace. If you want to deploy specific objects, first what you need to create? Create
namespace.
Next,
Deploy.
or service all in above namespace. This is the beauty. You have to go with this. Now, next time onwards, right? If you want to list, always you need to pass what is the command at the end. You need to append with the -n namespace. So with that, right? What namespace has been created? All our ingress controller are in which namespace now? Whatever that user right kinds, where they went.
Nginx. Ingress.
Nginx ingress. Now let's see kubectl get deploy fnl ingress Nginx. Deployment is there. How many pods are you told?
1.
In this deployment, how many you told? 1. How many are running?
0.
Why? See the reason. Get PO fnl ingress Nginx. What is this number? You tell me, what is this number?
Service
number.
Service ID.
Replica set.
Yes.
Right.
You know, right? Because of this deployment, one guy could have been created. Get replica set fnl. We don't check usually in the real time that replica set are here. So you have to think, because of the deployment, who will get created? Pods, along with it, one more object.
Replica set.
One second. Now you told one pod, but pod is in 0. Why? Pod, what is the pod status?
Crash loop back off.
This is our regular problem. Our day in, day out will deal with this kind of situations only. Our job will write, pod won't be running, developer will come. Something you need to check now. Why pod is crash loop back? You have to check all these reasons. Now, tell me, pod is deployed in which namespace?
Ingress Nginx.
Ingress Nginx. So, what is the pod status here?
Running.
Wait for some time. Now you see, right? Pod is, what is the status it is happening? Pod
Restarts.
Pod is restarting. Like pod is not running actually. Pod is getting crash. After some time it comes to running. Again it will go for crash. Pod is not stable. You see right here?
Yeah.
By default itself it is getting restarted. By default. Now till now how many times it got restarted? 7 times.
7 times.
It is restarting it. This is the one of your interview question, you will get it. Pod is in crash loop back. Pod is in pending. Now you tell me, if it is pending, what you need to do? We discussed it. What could be the problem? No resources, nothing worker. We told already these things, okay? What is pending? The last time we did it. We'll bring it back again. But right now, crash loop back. What we need to check? First, describe the pod.
Yes.
Check the logs. These 2 things we need to do. kubectl
Describe the pod name. -n Ingress Nginx.
See here, something liveness profile, seeing it. Something, go top, little top. It will tell you the reason also here, somewhere. It will tell you the reason also. Why it is, what is the status here?
Crash loop backup. Reason.
Crash loop backup. last state, it got terminated. Exit code 0. Restart count something 7.
7.
If you exit code 137, right? Observe here. In the interview, they'll ask you these questions. Okay. Exit code. Yeah, 137. Kubernetes. Because you give the less memory, but pod need more memory. This is the OOM killed. And what is the one code right now? What is this guy? Let's see. Exit code 0. Yeah, this is the problem. Why? Okay, let's see. Container marked OOM killed when non-init process. That's okay. Don't care. We will check the logs. This is first you have to do is the check this reason. Check if it is any status code. It is 0. For 0, most we will find in the logs only. Check it. To check the logs, right? Get the pod. Kubectl logs. There is a bug in their ingress controller. That's what you have to correct something. Or ingress Nginx. You have to read it here. You have to read this internal little. Thumb rule, when you are reading a log, right, always scan for error keywords only. No, you skip always this thing. Look for any error or warning something. That is what you should have a skill set. Somewhere error, shut down, like this keyword. Leader selected, exiting 0. What it is telling, why queue has been shut down, failed to enqueue. Attempting to acquire a leader lease. What is this, man? Shutting down. Yeah, shutting down. This is a SIG term. Timeout to catch a sync. Yeah. You see it? Yeah. These kind of keywords you have to see. Failed, fail, warning, error. This kind of keywords you have to see. So let me go first stop. Watching for SSL certificate. This might not work. That's okay. This is the maybe warning. Running Kubernetes cluster version. Fake certificate. Loading. Starting ingress controller. Yes, here is the one. And then you got it here. The server could not find the resource. This is okay. Failed to list. Let's see what is the answer we will get for this. And then creations. We need to Google, obviously. You have to find the reason. We need to Google it. This error also new to me. Some guy could have been filed a bug, right? See, this is the issue. Like me, like us, right? Someone could have been got faced. They could have asked these people, ingress people. They are part of the Kubernetes. I'm facing an issue with ingress controller. We'll put more. We'll put more like this. AWS eCase. The more search, we'll get exactly what happened with the mode. Let's see this kind. We'll go through this document. Even for me also, I'm saying this earlier. It is to work. I see some bugs were. It is related to support matrix. No? That telling version. Earlier we used to get exactly sync. I remember security group issues were coming. They fixed. They closed also this one. What is the answer they gave? Waiting dry as it is related to support. Check support matrix now. Using the issue. Something they tell you. Check this guy. Let's see this. What they're saying is you should go with this kind of matching version.
Latest version.
How to check our Kubernetes version? Let's see. Kubectl get nodes. This is our Kubernetes version.
7.
No. What is the version we went through? Did it say anywhere? Ingress controller version?
3.2.
Let's correlate. This is the guy is above. Let's go to the table. There are two legacy. I think this is Ingress Nginx version. This Helm chart version, Nginx version. Let's see Nginx version. Nginx version 1.17. Here, what is that one? 1.21.
One.
Okay. But if older version, what is the our version? 1.17. Still we are here. We should keep this level, I think. What is this meaning? Support. Should go with this matching. Somewhere I would feel that the proper matching is not working. We followed this. I think it should work. They could have deployed it. This control. This is control 0.32. This is open source one, okay? Whatever they are giving, right? This is open source one. We need to find AWS one. Exactly. This is the one thing we need to check. Yes, we have to check like this. Next one more. Let's bring the exactly AWS matching keywords. If you want to bring it, put the codes. Yeah. Offline model to in case yeah, this is the problem we were having it. Using Helm. No, we don't care about Helm. But you remember it failed, right? First, let me see that error. When we are applying itself, it failed it. The YAML. This is also one reason. Yeah. I need the errors. Bear with me for a few minutes. One is, yes, we need to check the versions. Version for we are following AWS document only, if you remember. 100% it should work. Somewhere we need to read their document. Let me go to their document only. They'll specify what versions we need to follow. This is the one only we went. This is 19. Is there any prerequisite? All are good. We are good with this. ALB, that's okay. Apply, defining English. This is the. Let me check with that versioning. Second, check the field. Third, check the code errors. Yes, I got the. I'm checking versioning. We checked it. Second error. We need to check this thing. Maybe because of this no matching kind. What we need to do for this? This is what when trying to apply custom ingress. They're telling give this. I'm installing it. I used to cloud rather than the bare metal version. No. Delete. Let's run this command. Get command you can run as many as times, not a problem. Be careful while deleting the other commands. We have AWS auth config, but what they're expecting is administration registration. Okay, it is. Let's go to here. Let me put it more e-case. We got it, yes. Such. There is one more document. Deployment. Let me see this. This is the what version? See. Get this sample. Which company? Yeah, this is the guy people only. You see right the document. This is the people only developed this initial this guy. I was telling right. The ingress controller. Their document. Then we are following their documentation. This documentation is not working. This guy is giving us the reference one more. Try this thing something. Edit the VPC proxy header range. Change the certificate manager. No, this is for Google. This is for AWS. They're telling it. So what went wrong? Let me check. This is the one we'll try. We'll try this attempt one. I'm noting down the points. Okay. We'll attempt it. Next, some more solutions. Want about the bare metal. I had the same problem found in this thread. Delete. Right. We should have an output what they're saying is as for this document. This one. We are not having that. Deployment. Oops. Something like this. I'm sure somewhere we are going with the versioning that I can say. Yeah, this is the YAML only we have seen it now. Let me try this YAML directly. Do we need to update anything here? Service account. Do we need to update anything? Something they were saying, right? VPC, SANA range, blah, blah, something. Let's see. This one they're saying. Which is the same document. Both are same. This document and this is our version. This is that it seems to be very good. Yeah, there is. This is the same problem we are having. Show us Kubernetes version 1.8 and updated 1.0 and it worked fine. No, but still the pod status is this is the problem we are having also same. In the logs, fake certificate, same we have the logs. Then how it came running. It did upgraded, huh? That's it. Just bear with me for a few minutes. This is very fake certificate. Fake certificate. Enabling since Kubernetes 1.18, we are good in 1.27 as per this. So let's see these comments first one by one. We don't have this thing at all. But I can say. From 277, 276. Let me apply again back the table. You can apply as many as times you see, right? Again, it says unchanged. This is the problem. Let's put it back up. Here, stuck. Various, where I got it. This one. If we put exactly matching keyword, EKS. Yeah, this is what they were. See, AWS have a user, right? They have a problem, but they'll make this kind of knowledge center articles. You guys getting here? We're getting knowledge center articles. Here, they will specify here something, how to solve this problem, and all they'll give this kind of documentation also for us. How to solve this documentation and that. I'll go through this. I'll not fix it here. Let me go through the some doc. We will see tomorrow. We'll continue tomorrow. Thanks, guys.